Welcome to our fifth presentation on LSK3701 Science and Technology Teaching in the Foundation Phase. I am your lecturer, Mrs. A. Carrim, and you can email me on ecarrier1@unisa.ac.za for any further support. I will be presenting Learning Unit 4 today. So this is the problem-solving nature of technology education. And on completion of this learning unit, you should be able to analyze and evaluate problem-based scenarios as a basis for planning appropriate solutions, apply appropriate problem-solving strategies to relevant examples given, and plan and write paragraphs to communicate ideas and opinions about technological literacy using appropriate academic and professional discourse. You need to be able to analyze, interpret, and make comparisons of different teaching approaches, such as technological problem solving, integration of mathematics, language, and creativity, and basically add a cultural historical perspective. You need to be able to identify suitable contexts for the application of these approaches and identify the strengths and limitations of each approach and suggest ways in which these approaches can be used successfully in a foundation phase classroom. You need to be able to use examples to cite the use of an approach appropriate for the learning context. So remember, the key concepts that we will be looking at in this specific learning unit is technology, technology education, technological literacy, problem solving, design process, creative thinking, and indigenous knowledge. So this learning unit introduces technology education in which problem-based approaches are followed, and this approach creates opportunities for the development of creativity during lessons that are focused on technological process. So what we need to first look at is, what is technology education? What is technology? What is technological literacy? What is indigenous knowledge? So remember, um, we talked about the important documents that need to be considered when teaching science. So you need to consider technological education in the South African curriculum, and also basically the design process and technological skills, which you'll be required to understand in Learning Unit 4 and 6, plus your information technology, which focuses on information processing skills, which will be more in detail in Units 5 and 6. So what's important is that the current curriculum policy documents are both the National Curriculum Statement, the NCS, as well as a curriculum and assessment policy statement, which is your CAPS document, that outline the aims of the South African education at, within the schooling level of grades R to 12. So this is very important that you understand these policy documents, and within this chapter, you will have a better understanding of what technology education is, what is technology, technological literacy, and indigenous knowledge. So please be aware of these concepts and take in as much information as you can so that you are able to give a good understanding and be able to give examples within these concepts. So what we're first looking at is technology education in the South African curriculum. So like I said, you need to be able to refer to those two documents that I've spoken about, that are the current curriculum policy documents, and that is your NCS and your CAPS document. What do these current policy documents outline? So remember, we spoke about it earlier also. It's basically the aims of the South African education, that basically gives you guidelines on what to teach. What are the 7 aims of teaching and learning in terms of the type of learners that should be produced? It's very important that students understand that the 7 aims would incorporate the use of critical and creative thinking, to identify and solve problems and to make decisions that are required, and working effectively as individuals and with others as team members of a team. It's very important that we instill, that we create group work activities in the teaching of technology as well, and be able to encourage organizing and managing themselves, in terms of within activities where they can act responsibly and effectively, to carry out a task that you've given them. And also, we want our students to be able to collect, analyze, and organize, and critically evaluate information that we have given them, and also communicate effectively. We want to encourage visual and symbolic and language skills. This is it's always good to incorporate language activities within our technological teaching as well, and also use science and technology effectively and critically. Basically, this is how we show responsibility towards the environment and the health of others. We want to make our lessons so effective that it actually allows them, to be able to use these skills in the daily challenges of life, and be able to demonstrate an understanding of the world, as a set of systems. And we want them to recognize that there is things that require problem solving. And if we put them in these problem solving contexts, we show them that they are able to solve these problems, if it's obviously at their level. And we cannot leave them in isolation. We cannot leave certain problems alone. Sometimes it does require intervention, and it requires the community to get together and try to help, in terms of recycling, or whether it be littering. So let us get our students involved in problem solving context, so that learning becomes more real and more more essential to our daily living. So what are the three learning outcomes for technology education described by the National Curriculum Statement, Technology Education, NCS? um, so this is where you describe, in terms of technological processes and skills, which is your learning outcome one, and technological knowledge and understanding, your learning outcome two, and the interrelationship between technology, society, and the environment, which would be your learning outcome three. Um, and then these questions that I've created is just so you can reflect while reading through your study guide. In the foundation phase, teachers are required to teach the technological processes and skills described in learning outcome one only, which is your technological processes and skills. So what does this outcome actually state? It basically states that learners will be able to apply these technological processes and skills ethically and responsibly, using appropriate information and communication technologies. And then you also want to decide, what do these learners engage in during technological activities. Remember, this is when they will engage in investigating, in designing, in making, in evaluating, and communicating solutions. And also, why would you use by using these process skills together? It is basically these skills are sometimes known as the design process. You will understand that you need to understand this design process, especially in terms of problem solving skills, because you will be expected to apply this in the examination, in the assignments. So please, you need to pay attention to this while going through this learning unit. So the design process is basically, and the related skills are the focus of learning units 4 and 6. So these skills are included in learning outcome one as part of the steps of the design process. Um, so I also would like you to consider assessment standards for describing the level at which learners should be able to perform the design process skills. Remember, at foundation phase level, we cannot expect them to do things that are, beyond their understanding level. So we need to work and adapt our teaching methods so that they are at the correct level of teaching. Especially with foundation phase, we want to create investigative uh, activities that are able to, give them the knowledge that they need, but not confuse them, and not make it complicated to a point where they're not interested in fulfilling the investigative skills. So you need to basically show the relationship between the design process and information technology education. So think about, it basically requires that learners be given the opportunity to learn the processes and the skills involved in using information and communication technology. So this relationship between the design process and information technology can be understood better in figure 4.1, which we showed in the previous slide, where it's showing that the design process and technological skills plus the information technology form the technology education in South African curriculum. So just go over this figure. It might give you a better understanding or a brief understanding so that you are able to understand how it works. Um, Now, remember in our initial slide, we talked about technology, defining technology. So remember, what is technology? So literature on the meaning of technology is very extensive. We can, with a click of a button on the internet, we can find a vast variety of definitions. But since we want to focus on a particular meaning, we have decided to use the definition of technology as given by the national curriculum statement of technology, where we will use the definition to clarify how technology should be taught and assessed. So this is the use of the knowledge, skills, and resources to meet people's needs and wants by developing practical solutions to problems, taking social and environmental factors into consideration. So we need our students to, have the knowledge, have the skills, and resources that can actually help them create these practical solutions to problems, within the social and environmental context. Um, so also let's look at what does technology find solutions to? So I think if you look at any examples, within the internet or whatever it may be, if people are, if we looking at a scenario like people arrive on Mars for the first time, there will be no structures to live on, no food to eat, no water to drink, no way to keep warm. So if people are able to survive on a planet like Mars, there would have to be a way for them to build shelters, to grow food, to harvest, and to have clean water to keep warm. They will need to breathe air at the correct levels of oxygen. They will need to eat nutritional food and excrete their waste. So these are things that we portray as human needs. So when knowledge, skills, and resources are used to solve the problem of providing for the needs of humans on Mars by building these structures, such as creating these wells for water and distribution systems. And this is where technology needs to be developed. So have you realized that water is a basic necessity for people's survival? And if it's not available on Mars, as far as we know, basically, so technology will basically impact on the environment. In this case, Mars, and there will be consequences for the small society. If people were to live in this situation. But if we look at within our context, if there is areas that don't have water, that would be a problem that needs to be solved. Um, so on Earth, similar developments have happened since the beginning of humankind. So using technology, humans have developed technologies in a variety of ways that change the way we get food, the way we prepare food, the way shelters are made, the way people communicate, and so on. So we need to consider all of this, how technology helps our environment, our society. So how does technology integrate with technological literacy? So this is also important for you to understand, um, because at the end of the day, technological literacy is important in basically developing and applying these specific skills, to solve the technological problems, and also to use it responsibly and purposefully, and create that interaction between people's values and attitudes, and society and the environment. So it's very important that we find the ability to find these solutions for needs, wants, and problems by developing technology, and also by designing and making and using technology successfully and wisely. This is what technological literacy means. It's not helpful for a person if technology exists, but a person is unable to use it. So this is where we look into more, get into more detail in technological literacy as per se. So this is where you have to understand what is the purpose of technology education. It's basically to contribute towards learners' technological literacy by giving them these opportunities for learning that allow them to have these specific skills to solve these problems, understand how to use technology responsibly and purposefully, and also develop that interaction that I spoke about in terms of their values and attitudes in between society and environment using technology. We also need to be able to describe the study area beginning, the beginning knowledge as noted in the CAPS curriculum. So you need to go over um, 4.3 in your study guide. So if you read these three opportunities for learning activities, you may notice the close link, between them and the learning outcomes for technology education. Um, and remember this, the beginning knowledge is described as the drawing together of content and concepts from social sciences, the natural sciences, and technology. So the social science concepts, you need to understand why are they related to the beginning knowledge. And remember, these are conservation, cause and effect, place, adaptation, relationships, and interdependence. We spoke about this in the previous units. In section A, we linked the social science concept to the so-called big ideas or big concepts of science. And you should be able to review the relevant sections for clearer understanding of these big ideas, since they also relate to technology learning. So it's not only for science, for teaching of science, but for teaching of technology as well, where you will have to understand it in lesson planning. So, what learning activities does the South African curriculum require teachers to carry out to develop these technological literacy in young learners? So, remember, it's very important that we develop these learning activities by using the design process and the design process skills. We allow our students to learn about technological products and systems and how they affect the environment and society, in terms of pollution and whatever the case may be, whatever topic you're going through, try to create that learning atmosphere where they understand how it affects the environment, how it's affecting the society, and what can they do to solve these issues or help solve the issues. We want to develop attitudes and values that are wise, and that are ethical, and that our students use technology in wisely and ethically. There's so much social media that our young learners are exposed to, and so many things that can go wrong if they are not taught to use it use it in a good way, and not to use it to bully someone or whatever the case may be. We need to instill these values in our students. Um, so, what is technological literacy? So, if you look at it in a broader aspect, it includes the ability to use technological products and systems responsibly and wisely with good attitudes and values. And let's think about a social problem. Our violent society. There are many children that live in areas where gang violence is rife, and children are killed in the crossfire, and their family members may even be gang members. Guns are found in their homes, not only for gang members, but of ordinary people. And who are trying to stay safe. So guns are a technological product designed to defend and kill. They are made with the use of tools. So we can definitely say that they are technological products, but they need to be used. Maybe for self-defense, and you need to have license for these guns. It cannot be used just because you're having a small fight and take it out and kill a innocent person, or something that can be resolved in a more more, just by talking, just by, it's not always where you need to pull out a gun or and shoot someone for no reason. This takes away a person's life. It has so many consequences. You can spend life in jail, and it's just so many things that can go wrong. So violence in schools is also a major issue, and young learners in many parts of our country are subjected to all these types of violence, not just gun violence. So how you react will depend on your attitude to guns and violence. So we need to instill good values in our students, so that they act wisely and ethically with these type of technology that are surrounding them. The social problem of violence has invaded our schools. We do not intend to give you answers to all these problems. only to challenge you to think about your attitude to violence and the safety and the well-being of learners you teach. So your attitude to violence and guns will be reflected in the kinds of drawings you allow learners to draw. You know, the kinds of toys you allow them to bring to class, or the toys learners can play with in their fantasy area in your classroom. So have you reflected on a society where violence is pervasive, you know? Should you allow toy guns or toy knives in your classroom? So we're trying to instill good values in our students. So we need to consider all of these. And as we have seen, for people to be technologically literate, they must be able to make certain decisions about the use of technology and technological devices. We have looked at one example of a technological product, namely guns. Moreover, access to the internet and social media. It also puts children and adults at risk, and people should therefore use this technology with wisdom. So technology education is a problem-solving activity, and teachers have to develop, activities that allow learners to find solutions to problems by using the process called the design process, which you will understand more in detail as you go along. Um, so it's also important that you understand the technology education in foundation phase is taught through the design process, including the concepts of social science. So this diagram, it's figure 4.2 in your study guide, that you can just understand how the learning outcome one of the NCS and the concepts of, social studies from your CAPS document actually give off, the technology education activities for foundation phase with a focus on the design process. Now we look at the problem-solving nature of technology. So you need to understand, I created these questions. So as you go along your learning unit, you are able to ask yourself these questions and reflect on this problem-solving nature. So what is at the heart of the design process? Um, Remember, this is the identification of everyday problems, needs and the wants of people, and the practical solutions are developed through this problem solving process. You need to understand what does problem solving entail. So it is a mental process that involves discovering and analyzing and solving issues. So the ultimate goal of problem solving is to overcome obstacles and to find solutions that best suits the problem, and thereby that's where you resolve it. The best strategy for solving a problem depend largely on the unique situation. So remember, you have to consider the context of the problem. So moreover, good problem solvers have a certain habits of mind, what we discussed in learning unit 2. And they need to also be able to illustrate simplified versions of a problem process. And what is the similarity and difference between the problem solving steps and the design process? Please, you need to understand this, because most of the time we expect you um, to use the steps to solve a problem. So those are the 5 steps, and obviously there's expanded steps of the design process, which you will see in your study guide on figure 4.3 and figure 4.4. So you can also read more about habits of mind for designers, technologists, and or engineers by following the links, or checking on the internet as well. In order to solve a problem correctly, it is important to follow a series of steps. Remember, these steps form part of what is known as a problem-solving cycle. So as you can see on the screen, you have the first step, which is identify the problem, develop alternatives, select the best alternative, implement, and consider if the solution worked. So this can also be understood in a more practical light by looking at table 4.1, where initially when you're identifying the problem, basically sometimes the problem is obvious, but you need to also be very clear about what the problem is, and after the problem has been identified, you need to actually define the problem, and so that this is when you can decide how it can be solved. And then when you look at developing alternatives, all of that, you have different scenarios that can work, and then, and then you select the best alternative. So the best way to solve the problem, and that's when you implement it, and then you actually have to see if it worked or not. So this is a very practical way to understand it, but you have to relate it to specific themes. So, for instance, in an assignment or exam, I could give you a specific problem that was, a scenario that happens in the school, and you have to identify the problem and consider, different solutions, and then select the best one and implement, and then test whether it's been working, has it improved, things like that. So also, I would like you to consider doing activities that show that you can apply this problem solving steps. And then you can look at the design process as taught in technology education. So what does the South African curriculum require learners to develop? Remember, we want to develop the skills necessary to perform the two processes during technology education. So one of these processes is the design process. The NCS describes the design process as a creative and interactive approach used to develop solutions, that identify problems or human needs. And the skills associated with this design process is basically we need students to investigate, we need them to design, development of initial ideas, make, evaluate, and communicate. So this can be seen in the expanded version of the design process. And that can be further understood in table 4.1, like I mentioned earlier. So if you look at these practical steps, you will find that it gives you a basic understanding, so that you can apply it to your own themes or questions that you get within this module. So remember, know the difference between the problem solving steps and design process, skill in the problem solving process, where you'll have 5 of them. So this is the shortened version: investigate, design, make, evaluate, communicate. Um, and then you look at, if you, for instance, we look at the Lexus designers, they said they wanted to design a particular type of car. Their problem was how to redesign a car that looked strong, that was comfortable to drive in the city, and of course looked good at the same time. So the design process then went on. When the designers did first, initially they need to do their drawings either on paper, computer, and then they noticed that the designers did not start designing a car from the beginning. So they started with an existing car and then changed existing ideas. So sometimes you can improve on something that is already available. And once you capture these new ideas in drawings, they can be obviously redesigned, and you can, check to see how it would look in real life. And that's how the process of design needs to be considered in the classroom. So sometimes we can take something that is not user friendly, or something that's not working effectively currently, and get our students to come up with new ideas. So this is how we get them to be business minded as well, where they can develop and design new products. And this is what life is about. As we go on with life, we get better at things, and things become more easier, especially if you hear things from your parents' time and compared to now, we see how technology has advanced in such a big way. We're making life much easier for all of us. So did you notice, if you as a teacher, you must bear in mind that when you develop lesson plans for technology education, you need to give teachers, our learners, individual time to imagine solutions and to draw their ideas using their creativity. This is where we encourage creativity, and there must be a time when we allow our students to explain their ideas to, whether it be group members or to the class in general. And this is how we can decide on the best idea, and then create teamwork, and value the input of each other, and teach our students about tolerance and respect towards their group members. So all of this processes involve a lot of like knowledge and understanding of how to work in groups and how to solve problems together and how to come up with ideas. So think of all the learning that is going on in this one lesson activity. So the design process taught in technology education is very important to understand and be able to apply, successfully, so that learners get the best learning experience within this type of technology education. So now let's look at creativity in the design process. These are also, again, questions that I've created that you can ask yourself while going through the learning unit. So what does the design process encourage? Do you think creative thinking is important? Reflect on this. If so, why do you think so? What is creativity? And how does authors describe creativity as? And how would you characterize creativity? What processes do you think are involved in creativity? What art activities do you think are important for learners to be given within this design process? And also, how does causal reasoning take place in the creative thinking? And what type of learners are South Africa's curriculum aim at developing? What do we want to develop in this country? What do we understand by visual literacy, and why do teachers develop this visual literacy in learners? So remember, the design process encourages the development of critical and creative thinking. So we will only discuss creative thinking since we believe that creative opportunities for learners are most prevalent in technology education, as the design process is followed. So, firstly, when we think of what is creativity, remember creativity is the thinking process that allows our students to express their new ideas. And Neyman 2014 writes on a blog that creativity at work, in terms of creativity, she sees it as the act of turning new and imaginative ideas into reality. So creativity is basically characterized by the ability to perceive the world in new ways, find hidden patterns, make connections between things that are between unrelated phenomena, and to generate solutions for this. So creativity involves two processes, which is thinking and producing. You always have to think of these creative ideas and then actually put it into action and produce them. So art, when we look at art drawings, activities that allow learners to use their imagination, and this is where they think creatively and innovatively. We'll see our students running towards our table and showing different drawings, and they get so excited, and you need to motivate this excitement, and as such, allow them to come up with these fresh solutions to problems. So an important aspect of creative thinking is that it is based on current understanding, of a person doing the thinking. Creative thinking allows for learning to take place also. So don't ever think creativity in the classroom is a waste of time. During creative thinking, it allows free exploration in the brain, and this is where causal reasoning happens. And learners will think about how changing something on their design will lead to a certain result. And it is through this reasoning that understanding of the world, whether it's natural and man-made, happens. And it's basically understanding that creativity can be taught, especially in the South African curriculum. It is basically aimed at developing creative learners. So, as teachers, we need to understand how creativity can be developed through good teaching methods. And, we need to consider creativity in children's drawings, look at their ideas and how you can help them make it happen in the design process. So remember, this is very important to understand so that you be able to apply it with an application question. Okay, so we're looking at indigenous knowledge and technological problem solving. So here also there's questions that I've derived, like what type of knowledge needs to be considered, as a creative way to solve a modern problem, considering indigenous knowledge and technology, and how indigenous knowledge is relevant for technology, and also describe the characteristics of indigenous knowledge. So, a creative way of solving a modern problem is often possible if one considers indigenous knowledge. We can't forget knowledge from the past or from, indigenous knowledge is basically a way of knowing and doing that local people have developed through the ages, as we're going about our everyday activities. So, why is it relevant for technology education? Remember, technology is basically a way of solving problems through developing and making products and systems. So throughout all the ages in humankind, we have been faced with problems with regard to food, to shelter, to health, to keeping warm, cool, and so forth. So these problems were basically already solved by there was times where solutions were developed from resources that were available in that particular area. But as life is advancing, we can create more easier solutions. So these solutions can become part of the indigenous knowledge of people living in that area. So it becomes a part of history. I'm sure in social science, you'll notice that we talk about inventions and how they are, keep on, inventions are keep on improving with each year. And that's why history shows where it started and where it's currently. So the characteristics of indigenous knowledge are as follows. So it's based on experience, in many cases, we'll consider was it tested over centuries, and also what data has been collected, observable knowledge about this particular solution and how it's adapted to local cultures and environments. Remember, certain things can work in all environments, and it needs to be dynamic and changing, and based on the application of problem solving, and also it can be taught to others orally or through storytelling. And we can't separate indigenous knowledge from ethics, spirituality, social order. All of this is very important, and it needs to bridge, within the science theory, the science of practice, and reflect ecologically based on the approach. And also, knowledge of science needs to be contextualized. So the context is very important. So, when it comes to indigenous knowledge, there can be scenarios where you're expected to apply, this understanding and why it's important in technology. So, you have an understanding of this and able to also apply it within the content or the lesson plan, or whether it's describing or explaining or evaluating this. Just have a good understanding, and also try to always, research more about these topic areas so that you have a broader knowledge and can bring up good examples that can give you, a broader understanding of indigenous knowledge and technological problem solving. Okay, so now we're looking at the content areas for technology education, which is also very important that you understand the three learning strands, which is technological processing, the systems and control, and the structures. So what you need to understand is also that that if you look at each strand, technological processing. This is a strand that focuses on practical ways, in which materials can be processed or manufactured in order to improve, and be more suitable for the intended use. So when you look at systems and control, this is the content area that is divided into mechanical systems and electrical systems. And, like if you look at how learners explore the systems and the control, in terms of context like transport, lighting, household devices such as washing machines, fridges, fans, all of that. And when you talk of structures, this is focusing on practical solutions that involve supporting loads and ways of making products that are tough, stable, and strong, where forces are applied to them. So learners can explore these issues with the context of, where it becomes housing, habitats, shelters, bridges, all of that. It needs to be, they need to form structures that can be, then can be used as models or whatever the case may be. So this is where we also bring in teamwork, creativity, design skills. All of that is very important. Okay, so let's look at language and technology education. Language and technology education is basically, you need to consider how to integrate language into technology education, how science activities can be incorporated into language using relevant examples, and also explain using examples how language can be used in the design process um, activities. So remember, integrating language into technology education leads to conceptual development in respect of language. So you need to refer to Learning Unit 1, where the focus was on conceptual change theory. So during science activities, learners, use scientific words, and this is how it's developed. So in the design activities, learners have the opportunity to use scientific words also as well. So this is where learners use language during discussions in their groups of what the problem is and how the problem can be solved. And this is when they explain their drawings and when they build and evaluate their models or solutions. So learners will use written language, when they complete their design folios in which they record the steps of the design process. So it's important that we have that similar. We make sure that similar learning happens. Um, for technology education where we integrate language, and this is also the case for mathematics. Remember this when it comes to mathematics and technology education, mathematical concepts related to space and shape and measurement are all developed in the design process. So in the design process, for instance, if they're making a car for traveling, learners will be talking about the wheels that are round in shape, and if it's a big or small wheel, in terms of measurement. So towards the end of the foundation phase, remember, learners start to measure in formal units, and but until then they use informal units. So nevertheless, measurement is a science process skill that needs mathematical conceptual understanding, and we want them to use measurement, during the design process. So they build maybe a model that is two-dimensional or three-dimensional, and that obviously we want to instill mathematical concepts in young learners at a young age so that they be able to design activities well in specific contexts that require them to do so. So this was actually also communicated with in the science section. So like you can see, creativity, mathematics, language, all of that is very important in integrating it into your teaching approaches. And you need to consider this when doing your lesson planning so that this module is basically done successfully in terms of, our markers tend to see that our students are integrating all of this and that they are able to apply their knowledge within all of these subject areas and obviously within the science and technology education. Okay, so this is basically a brief overview of Learning Unit 4. Please do not expect that going through this presentation is sufficient for learning. You need to do the activities, you need to work through your module site. There's some reflective activities that I've added. There's activities that you need to do within the learning unit. You need to consider the self-evaluation questions that in the study guide. And honestly, you need to ensure that you learn intensively, so that in this learning unit, basically you are introduced to the theoretical underpinnings of technology education in the South African curriculum. And after this discussion, you might be more understanding of technology and technology education and what problem solving nature of technology is. You also were introduced to the steps of the design process and the problem solving process respectively, and shown the similarities between them. So remember, the difference between the two problem solving processes lies in the nature of the problem identified. So the design process leads to a solution of a technological problem by means of a technological product. So this unit describe how technology education develops, it develops creative thinking in learners through the design process, particularly in drawing of ideas. And further points were presented on how technology education, language, and mathematics are integrated in the context of a problem. So I trust that this presentation will help you understand this learning unit better and get you started on trying to apply your knowledge. In the following unit, the next presentation, you will be introduced to information technology for foundation phase teaching and learning. So I hope that you will join me for that presentation as well. Thank you for your time and all the best with this learning unit.